pleasure to introduce my friend, Les McFadden, who is Professor Emeritus in the UNM Earth and Planetary Science Department. He received his master's and PhD in geosciences from the University of Arizona and a BA in anthropology from Stanford University. He served as chair of the Earth and Planetary Sciences Department at UNM from 1999 to 2007. And he is the quaternary, oh, I screwed it up anyway, sorry, Geology and Geomorphology Division of the Geological Society of America. He's also a fellow of the GSA. He has received several awards, including the Farouk El Baz Award for Excellence in Desert Research and the Kirk Bryan Award for Excellence from the Council of GSA. He is also one of 10 authors, editors of Climate Change in New Mexico over the next 50 years. Impact on water resources. This is part of the 50-year water plan that the governor has yet to release. You may also heard this report referred to as the Leap Ahead report. This was developed by the New Mexico Bureau of Geology and Mineral Resources, and Les just returned from the latest GSA conference where all the authors of this report were awarded the John C. Fry Environmental Geology Award from GSA and the Association of the American State Geologists. And just a personal note that this report and all of the webinars that came with it served the basis of 350's educational project, which is we're writing a curriculum for middle school on climate change in New Mexico. And that really, this report is what really spurred us to do that important work. So without further ado, Les, could you share your screen? We will be, if you have questions, please put them in the chat and we will look at those and Les will answer them at the end of his talk.
Does everybody see the presentation?
Yes.
Yes, but it's in presenter view, so.
Oh, I won't do that. I'm gonna, okay, I didn't know that was, okay, I need to end that show and, okay, I'm gonna screen share again. Okay. And I will open up this and I will open up, I will go to from beginning and I will.
That looks good.
Okay.
Good.
And,
Yeah.
okay, so you can all see it without presenter view, is that correct?
Correct.
That's correct.
Yeah. So I turned out I couldn't just automatically go to presenter view. Now I know that. Well, it's definitely good to see all of you today. If you have some questions after the presentation, ask them directly after unmuting yourself, and I guess you'll get those commands from Steffi a little bit later. And she's already mentioned a bit about the report, so I'm just going to move along. Most of you probably know that New Mexico is a very energy-rich state. This map of New Mexico shows regions where substantial coal, oil, and gas resources have been identified on the basis of many previous geological studies. Compared to the other 49 states, New Mexico ranks fairly highly with respect to production of carbon-based energy resources. For example, we're number 10 with respect to coal production, at least as of 2019. In terms of natural gas production, we move up to number 8, and we're almost the big winner for the gold medal in crude oil production at number 2, second only to the fine state of Texas. Oil and methane production in New Mexico contributes a great deal to its economy, supports numerous jobs, and as recently over the next several years, will continue to provide a substantial fraction of New Mexico's annual budget. It all sounds good. However, one of the major consequences of the production burning of fossil fuels, as you all know for sure, being members of the 350 organization, is that when you burn them, you produce carbon dioxide and you release, in some cases, a substantial amount of methane, virtually all of which is released into the Earth's atmosphere. How do the releases of these greenhouse gases affect Earth's atmosphere? Well, these two figures show key takeaways from the recent IPCC report. The figure on the left shows that after several centuries of cooling of annual global temperature, the actually observed global climate temperature has increased substantially since 1850. Well, the figure on the right shows this isn't just chance. It shows from simulation model results for the impacts of greenhouse gases versus no increases. The simulated temperatures are correlated with the observed temperatures that are directly associated with climate input. So there's no doubt, at least in the minds of climate scientists, paleoclimatologists, et cetera, there were the cause of that dramatic warming in the last over 1 century. Is this increased global warming affecting different areas of the United States in a clearly discernible way? Well, and here you go. This is what I thought I'd add to it, Steffi. My wife and I just returned from a trip to New England, during which we checked out Mount Washington in New Hampshire, which it's the tallest peak in New England at a lofty elevation of 6,222 feet. We boarded the famous cog railway train built in the 19th century, a true engineering feat at that time. And this is what it looks like when you're ascending a very steep mountain on the cog railway. It's kind of scary, actually. As the train nears the summit, one sees the impacts of much colder climate on physical weathering of rocks caused by frost shattering. And at the summit, there's a big visitor center. And when we arrived, temperatures were well below freezing, as you can see here, considering the rime ice formations on the rocks, weathered rocks. But here's a punchline. This is what's displayed in the visitor center. An example of how human-induced climate change has impacted New England's climate during the last 90 years. Well, global warming has also impacted New Mexico's climate. This graph shows observed significant increase in mean annual temperature in New Mexico over a 90-year period. As will be discussed in this presentation, climate change is already impacting New Mexico's water resource in some obvious ways. In other words, it's not going to happen in 30 or 40 or 50 years. It's happening now. For example, we see lower stream flow and groundwater recharge because of increased aridity. We're already experiencing hotter, more severe, and lengthy droughts. We're observing a decreasing snowpack with earlier and diminishing snowmelt runoff. We see, as a result of this, greater demands on our groundwater. We see stress on our vegetation communities throughout the state. And we're experiencing increasingly catastrophic forest fires, which I'll be getting to in some detail later in the presentation. We're also seeing evidence of increasing flooding and sediment transport. Many publications, the Albuquerque Journal articles, were describing how climate change could also seriously affect your personal finances. So if you're not worried about changing climate, I guess you can think about your pocketbook. So there have been some encouraging, for the most part, political responses in New Mexico to date. After all, we are now officially, as I understand it, a blue state. We saw the Energy Transition Act passed by the New Mexico legislature in 2019, the key goals of which were to move to a more sustainable energy production. The legislature also sponsored a New Mexico Climate Summit in 2021. The legislature passed methane regulations in 2022. And Senate Bill 5 was passed in the recent session, which provided funds to support a public health and climate resiliency fund, starting with $5 million more and more to come, we've been told. Also, at the local level in Albuquerque, the mayor and his administration passed a climate action plan with a survey and a climate task force. I will admit, unfortunately, key bills passed during the most recent Mexico legislation, or key bills that were presented to the legislature, that were passed by the legislature during the most recent legislative session to address ongoing and future climate changes, were vetoed by our governor. Some of these projects that would have been supported, including research in geothermal activity, credits for electrical vehicles, energy storage for businesses and homes, and rebates for electrical heat pumps. A bummer, but we are doing some things. So most of these actions to date are commendable, but what should states subject to increasingly hotter and drier climate be planning for the next several decades in an informed manner to prepare for the impacts of future climate changes, particularly on a critically important research, at least in this arid state, and that's freshwater. Accordingly, a project was designed with the ultimate goal of creating a New Mexico 50-year water plan. The development This plan reflected the collaboration between two state-funded agencies, the New Mexico Interstate Stream Commission and the New Mexico Bureau of Geology and Mineral Resources. This effort also involved an assessment of closely related features such as New Mexico's vegetation communities, deserts, mountains, rivers, and soils. Dr. Nelia Dunbar was selected to serve as a director of a panel of climate and earth scientists whose task was to develop a formal report to assess the impacts of climate on New Mexico water resources over the next 50 years. As you can see, Nelia has a lot of impressive titles. And as you will also see by the end of this presentation, she was a hell of a director. I really came to deeply admire Nelia, even though she's a metamorphic petrologist. That's an inside geology joke. My apologies. At any rate, the ground rules of the study conducted by the panel were as follows. First of all, the general goal was to assess and synthesize recent scientific literature on climate, hydrology, and the impacts of climate change on water resources. So this included an assessment of future climate projections for New Mexico specifically, changes to our surface water budget, ecological dynamics in our various and diverse plant communities throughout the state, landscape change, fires and erosion, studies and evaluation of changes in extreme precipitation flooding, soils, rivers, water supply, and water quality. So we were to address all of these insofar as we could at least try to understand how ongoing and future climate changes over the next 5 decades would affect, at the end of the day, our water resources and other environmental aspects in the state. So I want to talk a little bit about the panel. The panel was basically an experienced team of New Mexico research experts, and they were assembled to work together and assess the state of knowledge and develop a review report. There were 2 co-chairs appointed by Nelia. The first was David Gutzler, a colleague of mine and friend at the University of New Mexico, Earth and Planetary Sciences Department. He's a professor emeritus in that department. And again, he was the panel co-chair. I might also mention that Dave Gutzler is recognized as one of the world's great climate scientists. He's been head of one of the key chapters in the IPCC reports, at least over the last 3 of them, that focuses on research. So a remarkable scientist. The other co-chair was one of the United States' top hydrologists, a professor emeritus at the New Mexico Institute of Technology, and that's Dr. Fred Phillips. And here's the rest of the panel. Ecologist and adjunct professor Craig Allen was selected. Although he spent most of his career with the USGS up in the Jemez Mountains, he's now an adjunct professor in the Department of Geology down at UNM after retiring from his former position. David Dubois, climatologist, the New Mexico State climatologist and director, and also involved in the New Mexico Climate Center. He's an associate professor in plant and environmental sciences down at New Mexico State University. Phil King, water resources engineer and associate professor and chair of the civil engineering department, also at New Mexico State University. Bruce Thompson, environmental scientist and engineer, and a research professor emeritus also at UNM in the Department of Civil Construction and Environmental Engineering. And I might also add an exceptionally good violinist and bluegrass musician. Ann Tillery, one of my former graduate students who was a specialist in surface systems in working for the USGS, which stands for U.S. Geological Survey, in the New Mexico Water Science Center. Michael Harvey, a water resource engineer working for TerraTech Incorporated, located in Albuquerque, New Mexico. And last, and hopefully not too least, me, I'm a soil geoscientist in the Department of Earth and Planetary Sciences, as Steffi mentioned. And there were many others involved in this project, for example, peer reviewers from New Mexico Bureau, and individuals also working for the Interstate Stream Commission staff members, all of whom also deserve some acknowledgements. So it would be great to have the time to present some examples of the key conclusions of all of the panelists presented in the published report, but I don't. So I'm going to focus on some of the selected key results from a subset of those panelists. Let's start with a few with a few of some of the key results and conclusions from chapters 1 and 2, authored by Dave Gutzler, Dubois, and Nelia Dunbar. A particularly important conclusion is shown by this figure. One important takeaway: the average annual temperature increase of 2000 as of 2020 already exceed the previous several decadal averages by slightly over 2 degrees Fahrenheit. If the rate of global greenhouse emissions remains high, in other words, business as usual, as IPCC calls it, excuse me, I'm sorry, my apologies. We could see an average annual temperature of up to 14 degrees Fahrenheit by the year 2100. New Mexico also has highly variable precipitation, as all of you surely know, and likely will be even more variable with increased warming. Model results indicate that annual average precipitation may not change at all, but future drought episodes will certainly be more severe due to an increasingly warmer air. Warmer air can hold more water vapor, and this ultimately causes greater losses of water from soils and plant leaves, which contributes to something called aridification, which I'll be getting into in some detail. Also, as soils become drier, remaining water is more tightly held by soil particles, and the consequences from these processes, again, is generally referred to as aridification. The magnitude of aridification can be quantified and represented graphically by calculating an index called the aridity index, which is simply the ratio of average potential evapotranspiration to average precipitation. For some of you who don't know what the term evapotranspiration means, it's just simply the sum of direct loss of water from the soil or from the surface by physical evaporation. Transpiration is the loss of water vapor through plant leaves, in other words, water given up by plants as part of their biological processes. This index is essentially the amount of water that could be evaporated from the surface if the water was actually available to be evaporated. Aridification is affected by absolute humidity, which in turn is influenced by windiness and insolation. These maps show predicted increases in aridification over the next several decades. And I might mention that aridification is actually pretty substantial if you know, at least from a quantitative sense, what aridity index is actually measuring. This shows how the aridity will increase in terms of percent, comparing two records from 1970 to 2000. In other words, actual data, and then predicted based on this modeling in the years 2040 to 2069. And again, we're talking about substantial increases in terms of percent and aridity just over the next several decades. And if you're looking carefully at this map, you'll notice the aridity will increase the most in a relative sense in the highest elevation areas of New Mexico. And that's simply because there's simply more water to evaporate at those higher elevations because of the average annual rainfall and reduced evaporation that occurs at those higher elevations. Earlier snowmelt and loss of snowpack driven by warming temperature correlates with diminished snowmelt runoff. Also, spring precipitation as an increasingly important component of headwater flow as snowpack diminishes will change. So the relatively confident projection of decreasing spring precipitation portends also diminished water flow as temperature increases and the snowpack declines. So bottom line is all bad news insofar as freshwater resources are concerned. The present knowledge of atmospheric processes in some models indicates that extreme precipitation events will happen more frequently and will be more intense. And this is sort of exemplified by recently observed unprecedented rainfall and flooding in New England, which ruined one of the motels I was going to be staying in with my wife in the last couple of weeks, and also very recently in Libya and other countries. This map shows the results of a model published in 2018 that shows probable maximum precipitation for a local storm covering 10 square miles and lasting 6 hours. So what we're looking at is increasing likelihood of extreme storms from west to east across New Mexico. And, we're also looking potentially a pattern that global warming will probably substantially magnify. So runoff is a term that we geomorphologists use to describe the fraction of rainfall that does not infiltrate into the soil or is uptaken by plants and flows downslope over a land surface. So what's going to happen to runoff, which of course is one of the direct inputs into streams, lakes, and groundwater ultimately? Most models estimate declines in runoff, but there's a lot of uncertainty. And the uncertainty has to do with the many variables that actually influence runoff in a variety of different frames based on changes in variability in vegetation types, density, canopy cover. The declines will be observed in water level in many New Mexico aquifers, but again, it's difficult to separate declining recharge associated with declining runoff from the pumping effects due to increasing runoff. But certainly we're going to see declines in the water level in part as runoff declines, at least at some level. So despite uncertainties in future predictions of both recharge and runoff, all indications suggest less of both due to increased evapotranspiration due to warmer air temperatures. And no surprise, average Rio Grande flows increased 4% since 1997. And that's a tight number. There's no doubt about that and about what's likely causing it. Craig Allen's research reveals the ongoing impacts of climate change on ecological dynamics of vegetation in the Jemez Mountains. Repeat photos of landscape scale mortality of pinyon or Pinus edulis from hotter drought and associated bark beetle outbreak. He shows the following. This photo shows rust-colored dying pinyon in October of 2002 at a site in the Jemez. And only 2 years later, after following drought, this is the same scene showing extreme high mortality with great pinyon skeletons and only very few remaining live junipers. So basically what we're looking at, and this is a drought that occurred in the early part of the 21st century, is essentially the extirpation of pinyon juniper forest in many parts of New Mexico, with worse to come, unfortunately. So due to hill slope orientation related impacts on insolation, that is energy received from the sun, and this orientation also affects soil moisture content, the distribution of major plant communities such as the ponderosa mixed conifer community and the spruce fir community are present at different elevation ranges on the south and north oriented hill slopes. Accordingly, one probable response of vegetation communities to a warming climate acidification is migration to either higher and cooler elevation settings, or they just simply migrate northward to a generally cooler climate. I'll mention later that we use this relationship to help us understand not just differences in climate that are due to what we call aspect or orientation relative to the sun, but can be used to help us understand the impacts of past climate changes in our state. So, unfortunately, ongoing climate change will also cause increased incidence of wildfires and associated landscape changes, making recolonization pretty challenging. So, the Las Conchas fire in 2001 burned more than 150,000 acres in the Jemez Mountains. Now, what do wildfires do? They greatly increase hill slope runoff because of the dramatic reduction in canopy cover and soil strength owing to the loss of that vegetation and the root networks. So what has this resulted in ultimately in parts of the Jemez Mountains? Craig studied essentially something called desertifying. In other words, 20 years or 12 years after this fire occurred, there's essentially no evidence of recolonization of many of these landscapes by either pinyon or juniper. And of course, that's happening for largely two reasons. One, elevated average annual temperatures making recolonization hard, increasing soil temperatures, and also the loss of canopy cover. Essentially, you've got virtually no shade, and that alone would increase soil temperatures beyond that caused by global warming. So, what are some other landscape changes that can result from climate change or accelerated by wildfire? And this is the result. This is some of the material that Ann Tillery and others presented in their chapter. First off, as I just mentioned, increased overland runoff, hill slopes and flooding, increased upland erosion and downstream sedimentation, which I'll be getting to in greater detail a little bit later. Mountainous areas will be most impacted. Arroyo formation can be initiated or accelerated, at least in some areas of New Mexico. And there's an example of an arroyo that has formed, probably started forming in the late 19th century and early 20th century, we think mostly as a result of climate change. And if we're right, we're going to see a lot more of these forming as a result of global warming, increased intensity, length, and strength of drought. All of these impacts disrupt normal drainage systems and damage infrastructure, as an aside. So another important frequent impact of wildfires, and these are called debris flows. And what is a debris flow? Well, debris flow is a type of mass movement that's derived from hill slopes located upstream from a site I'm going to show you in a minute. The loss of forest canopy increases the direct impacts of rainfall on hill slopes, which in turn increases runoff and erosion, as I just mentioned. However, in many cases, these processes subsequently trigger increasingly larger and devastating gravity-driven mass movements. And here's an example of the results or the consequences of a great debris flow in the Jemez Mountains, one of which Ann Tillery and her colleagues in the USGS studied. Just to give you a sense of the size of the boulders in this debris flow, there's the gate that it almost smacked down, destroying the road, of course, above it completely. The reason debris flows can do this is that debris flows are given the fancy name of non-Newtonian fluids. In other words, they have the capability of actually supporting very large boulders and then carrying them for several kilometers from their original sources. And you might, if you've been following it, the news in the Calf Canyon, Hermit's Peak wildfire, there have been many debris flows, some of which have completely destroyed structures in that area. And in the paper, I think it was an article in the paper today, actually, entire family was wiped out by one of these debris flows. They're dangerous. So what we're looking at here is some of the work of Mike Harvey on rivers, and he concludes generally that climate warming impacts will accelerate increases in sediment loads in many stream channels. So he's a fluvial geomorphologist, and what is this increased sediment load? That is the load of material that is actually being transported by the stream. And that includes its bed load, the coarser material, gravel and coarse sand, material that is moving by another process, which is a little more complicated, which I won't get into, called siltation. And then suspended flow. The reddish color of the river you see there is reddish clay that's been suspended and is basically buoyed up by forces associated with turbulent eddies in turbulent flowing streams. So we have an increased sediment load in many stream channels, but that will be coupled with decreasing flow volume. Increases in hill slope erosion and deliveries of sediment to stream channels, such as wildfires, are going to be influencing this and dramatically increasing that suspended load. We expect there will be many increases in extreme precipitation events, which will also enhance erosion and increase stream load. And those processes in turn will cause the fancy term channel aggregation, which simply means the accumulation of sediment in the beds of the stream channels. So these sediment load increases will continue to change channel character. In other words, the actual width, depth, and of the stream itself will change. And this will also have negative impacts on Mexico's historic and extensive acequia systems. Also, the increasing recruitment of river corridors by non-native plants and diminishment of native plants and channel narrowing are expected consequences of some of these changes in fluvial, or that is, stream processes throughout our state that can be directly tied to increased global warming. And increases in sediment delivery to the reservoirs will reduce reservoir capacity. So some of our large reservoirs, what this is saying is they're going to get filled up more quickly. And once they fill up, it sort of eliminates the point of having a dam in the first place. A study by New Mexico Environmental Department illustrated the main impacts of future climate changes on surface water impairment, streams and rivers in New Mexico. This figure shows that there will be several important impacts, but clearly the biggest impact will be an increase in water temperature. So let's look at that a little more closely. This figure shows hourly stream temperatures for a 7-day period for different vegetation scenarios associated with stream channels. The base case in the black color is a bottom, is just simply the conditions for air temperature at a given stream discharge. Discharge is a fancy way for saying the volume of water flowing down a river over a given stream reach. The bottom line is this: the presence of forests associated with streams lowers stream water temperature by providing shade. But wildfires that largely remove the forest on nearby stream banks or terraces increase water temperatures, especially mature riparian forests. The riparian forests are those forests that are largely supported by the availability of shallow groundwater. And at lower parts along the stream that have relatively slow stream velocity, when you combine that with warming, we already see evidence for increased formation of what's it called? What's it's a pretty awful plan. I can't remember what it is right now, but it's not a good thing. Oh, there it is. E. coli. How could I forget that? Getting old. So how will future climate changes affect New Mexico's soils and landscapes? The principal question addressed in the chapter of which I'm the senior author. Well, several factors strongly affect the formation of soils in our state and its diverse landscapes. These include things like different geology of many places in New Mexico. In other words, the different rock types that have evolved over the last 1.4 billion years in our state. The great diversity in the climate of our state, diversity of vegetation in our state, and highly diverse topography in our state. So the result of these very different soil forming factors, we have many soil types in New Mexico, and these include desert, grassland, and montane soils, which are all quite different in their morphology, chemistry, and mineralogy, and organic material content. So when you're going to try to understand how climate change will affect soils, you have to keep that kind of soil diversity in mind. But just in terms of some basics, here's a picture I took from the summit of Mount Wheeler when I still had the knees to be able to hike to places like the summit of Mount Wheeler, the highest peak in New Mexico. So if you take a look at this photograph, you're looking at a lot of terrain over an elevation of 10,000 feet, because Wheeler's at the top of Wheeler's over 13,000 feet. The lighter color areas are areas of either exposed bedrock or material we call talus. And those areas are essentially devoid of soils, but everything else you see in that picture that's green means that there's a pretty consistent vegetation canopy, and in most cases, a continuous forest canopy. I guarantee you that wherever you see a continuous vegetation canopy, it's associated with a continuous soil mantle, because mantles are required, soil mantles are required to support virtually all vascular plants. And another thing to keep in mind as I move more into this topic, a large body of research shows these soils take thousands more years to form. So why are soil foils important? Well, one really important aspect of soils from a hydrologic standpoint is to try to understand what happens to rainfall after it actually lands in soil, as opposed to, say, another surface devoid of soil. Well, what happens to water? Okay, well, there's oh, by the way, those numbers you see there, those are indications of the relative fractions of water in terms of their fate or related to different processes after the rain falls. So the first thing that happens when you have precipitation is a significant amount of infiltration. That's water that just simply crosses the atmosphere soil surface boundary. Some of that water is retained in the soil and then can be uptaken by plants and transpired by those plants. Some of the soil water directly evaporates to the atmosphere, but some of the water actually can move quite deeply and actually become groundwater through a process known as recharge. Now, this is relatively horizontal. Well, this is a horizontal surface as shown in this particular graphic. But on steeper surfaces, I think you can all imagine that the component of runoff will be larger and proportional to the actual slope, the slope angle. So let's take a look at some of the, now that you understand the significance of soils in terms of its influence on rain or precipitation, let's take a look at a few examples of diverse landscapes in New Mexico and their soils and consider how the soils that characterize them might be affected by climate changes over the next several decades. One important landscape that's spatially extensive in the Southwest is the Colorado Plateau, which actually represents a fairly large part of New Mexico. There's the Colorado Plateau, and you can see that it's a very large part of the northwestern part of our state is topographically referred to by geologists, or physiographically referred to as the Colorado Plateau. Many areas of the Colorado Plateau are covered by wind-blown sand, such as these beautiful pink sand dunes found in the southernmost part of Utah. One of the key factors that favors the transport and accumulation of windblown sand on the Colorado Plateau is wind, and in particular, the seasonally strong prevailing southwesterlies that characterize latitudes of this region. Another is a great abundance of sandstone in this region, such as these fossilized Mesozoic sand dunes that can be found in Zion National Park. These rocks weather the loose sand, which can then be blown by wind to eventually accumulate as modern sand mantles or sand dunes. Now, previous periods of slightly cooler weather during the last several centuries has enabled certain types of shrubs and grasses to actually recruit many of the dune mantles on the Colorado Plateau. And that's what you're looking at in this photograph. The Moenkopi Plateau is a large region in the northeastern part of Arizona that my colleagues and I and students have been studying for some time. Now, this process of colonization of the dunes completely stabilizes these otherwise sand-dominated landscapes in the Colorado Plateau. And this photograph shows an area that was once, again, covered by completely active dunes probably several centuries ago. How will recent warming and aridification affect these kinds of landscapes? Well, we're already seeing, as one might have anticipated, recent extended droughts and increasing temperatures have increased aridification and greatly diminished vegetation cover in many areas. The loss of stabilizing vegetation is triggering renewed sand movement and dune migration. This in turn is having largely negative impacts on the Dene Nation, which occupies a very large area of the Colorado Plateau. A research conducted by one of my former students, Amy Allwine, focused on the impacts of past climatic changes on those extensive alien landscapes of the Colorado Plateau that I just mentioned. The linear dunes in this region that she mapped and studied are shown in black on this map, which again represents an extensive part of northeastern Arizona. Now, as noted previously, many of these dunes were stable for thousands of years, enduring unexpectedly moisture and cooler conditions, enabling well-developed clay-rich soils to form in those dunes. And that's of course what I study and my students. Now, this recent aridification recent aridification is subjecting some of these soils to more of the wind, the processes associated with wind, which we call deflation. And essentially what that's doing is blowing a lot of the dust into the air. And the arrows in the map show the direction and strength of the winds on the Colorado Plateau in the southwest and their ability to transport this fine sediment blowing off these now eroding soils. A significant sink for most of this dust are the higher hill slopes of the lofty San Juan Mounds and the Santo Cristo Mounds and the Southern Rocky Mounds, which in turn diminishes surface reflection, a surface parameter known as albedo. A darker surface or decreasing albedo increases surface adsorption and heating. So in addition to increasing temperature, this process accelerates the loss of snowpack. And as noted previously, a diminished snowpack has mainly negative impacts on runoff and stream discharge from these high elevation settings, the major source areas of freshwater New Mexico, as well as much of the Southwest. So there's something else we get to look forward to. Much of eastern New Mexico is dominated by the southern high plains, and as you can see in this photo, is a region dominated by many areas by shortgrass prairie. So how will continued drought, vegetation, and cover reduction and aridification affect these landscapes? Well, we have a pretty good idea. In the 1930s, the last time New Mexico and other surrounding states were subject to several years of drought and aridification, this is what happened. This period, of course, is known as the Dust Bowl. There's no reason to think that many parts of New Mexico, as well as the rest of the Southwest and Midwest, might not be facing the same fate in the not too distant future. This is a photo taken in 1935. Really remarkable. Those are wind ripples, by the way. Once you get an accumulation of loose unconsolidated sand on the surface, then higher wind velocities can mold that sand into these wind ripples, sort of emphasizing the end of the line for agriculture, at least that part of New Mexico back in the 30s. Well, New Mexico also has extensive, relatively high elevation and mountainous regions. And before I get into this, how am I doing for time, Steffi? Can you hear? I guess you can't hear me. Getting over. I'm going to sort of rush through this pretty quickly. My colleagues and I do a lot of work looking at the impacts of climate change on hilly regions. And a lot of New Mexico hills at elevations of 5 to 6, 7, 8,000 feet are covered by pinyon juniper. And when you look at the north-facing hill slopes, this is what they look like with a nice PJ cover. But if you turn around and look at hill slopes that were right behind me when I took this photo, the same exact rocks don't show a nice smooth surface. They instead show these really steep cliffs and a virtual lack of soil and very sparse vegetation. So this reflects, again, something I mentioned earlier, which is different aspect. Those northern hill slopes are cool enough more of the day than the southern facing hill slopes because of our position in the northern hemisphere. And those conditions on the north actually help to retain more water and generate weathering, which produces that nice smooth surface. When you begin to lose that soil with climate warming and drought, this is what happens. And this is what my colleagues and I have published in a couple of papers. So I want you to focus on this area here. Now, this area here is located exactly between the north-facing hill slopes and the south-facing hill slopes. And the reason why this is such a critical area is this. You're looking at a bedrock at a slope that was covered by soil only a few centuries ago. And the reason we know that is when you look to the right of that reddish circle, you'll see plants that are called cliff rose that are growing in soil. In the lifetime of those plants, that soil has been completely removed, exposing the roots that had recruited the bedrock soil interface, and that's what my colleague is looking at. So again, this area that today is bedrock, and just a few centuries ago was a smooth hill slope with a continuous pinyon juniper community. So what is this telling us? Well, let's look at those rendered patches of soil and cliff those plants and imagine what used to exist and what exists now. We know from the age of cliff roses that this had to have happened in the last century. And our conclusion is that these hill slopes are incredibly sensitive to very recent climate changes that have increased soil erosion, removed the soil, and are causing the incredibly rapid, complete transformation of these hill slopes to steep cliffs and steep bedrock surfaces. And this is something that my colleagues and I have observed throughout much of the Western United States. It's probably going on worldwide. So how could a recently warming climate cause these dramatic changes? And I'm just going to go quickly through this. Increases in drought and warming on an initially smooth vegetation hill slope reduces the plant cover, increases runoff and erosion, decreases soil cover, increases soil erosion rates and stripping of soils. This is a positive feedback because it exposes significantly less permeable bedrock and generates even more runoff and converts the slope with the slope to steeper bedrock slopes and cliffs. And a key point here is that this process is essentially reversible in human timescales, that is many, many human generations. So they're not going to go back to those nice, smooth soil mantle vegetation in anytime soon. So some people think, well, at higher elevations, there's enough rainfall, it's cool, that we don't have to worry about these kinds of terrible things that are going to result in dramatic loss of vegetation, dramatic loss of soil, dramatic changes in hill slope form. It's not going to happen at higher elevations because here's what it looks like in a recent photograph I took in the high Jemez Mountains. But this is the problem, it's fire. And what's fire doing throughout New Mexico already? Well, the fire removes much of the vegetation canopy, the raindrop hits the soil, the raindrops run off. As you get more runoff, you get more rilling, as you can see here, stripping of the soil. And in many cases, you get a process known as bulking, that is material running off has a higher and higher concentration of eroded soil, and it turns into a massive debris flow. And of course, this is going on right now in the hundreds of thousands of acres that were burned during the Cap-Coward Hermit Peak fire.
Les, you've got about 4 minutes.
I'll continue. So I'm right near the end. Remember this photo of the alpine hill slopes I showed you? So this is what we think is going to happen to these areas everywhere throughout New Mexico at higher elevations. This is the post-Las Conchas fire landscape in the Jemez Mountains. As you can see here, the forest has been entirely removed, exposing a lot of that bedrock, and now that soil is being actively removed. This is a summary we gave in the paper, and I'm just gonna skip over this because you've heard about it, but these are all the things that you can read in the paper that's going to happen over the next 50 years. Just a quick chance to look at that. So I want to get to this though. My friend and colleague, Dave Gutzler, received the 2014 New Mexico Earth Science Achievement Award, and in 2018, the 4th Annual Community Engaged Research Award. At the end of his presentation, he did something he didn't usually do. So people asked him, well, what's it going to look like? What are the sand dunes going to look like in 50 years? And this was the answer he gave. It's going to look like the Franklin Mountains just north of El Paso. I was a little skeptical that the sand dunes could change so dramatically in such a short period of time, but then I thought about this. Remember this photograph or this graphic that shows the different elevations of different plant communities on north versus south facing sites. Well, when you go into an ice age, plant communities simply move down to lower elevations to avoid the cooler temperatures at those higher elevations. But at the end of an ice age, when it warms up, the plants move back up. So a lot of people think, well, that's what's going to happen. Those plants can just move up. But if the soils aren't there, you're going to have some pretty darn sparse forests because you simply won't have the soil to support recruitment by those forests. So we're really, for a number of reasons, looking at the complete loss of most of New Mexico's forests over the next 50 to 75 years. But it's not so bad. I'm a desert geologist and a desert scientist, and I happen to like Ocotillo. We'll probably be seeing a lot more of these in our lifetime. And that's it. Thank you very much for your time.
Thank you, Les.
I'll stop screen sharing. Will we do that, Stephanie?
Yeah, that'd be great.
Okay.
Thanks. We only really had one question.
Oh, I have 16 in my chat box, but go ahead.
Yeah. And that was Paula Claycomb.
Mhm.
Would you like to ask your question, Paula? And unmute.
Well, thank you very much. I enjoyed this very much, although it does give me the shivers, of course. But I guess I'm always left with the question about what we do here in New Mexico is effective in light of overall efforts similar to ours, and the continued denialism on so many fronts that it's impossible to enumerate them. So what I'm wondering is, what do you think, Les, that we can do in New Mexico that will not only benefit our homeland, as it were, but also impact more broadly at the national and global levels?
I had someone in one of my recent presentations on climate change asked essentially the same question. And it's not an easy question to answer. It sounds like well, anyway, here was my answer. Well, number one, by adopting a wide variety of practices that are designed to diminish significantly the production of greenhouse gases in our own state, of course, that's not going to dramatically affect the English climate. It's just New Mexico. But we serve as an example to other states that it can be done. And I think that's one of the most important things you can do, is to demonstrate to those states that are resistant to change, to show that it can be done. And hopefully, if we can actually dramatically reduce CO2, methane, et cetera, we can actually quantitatively show that snowpack is no longer declining as fast as we see it declining now. We might actually be able to see some positive change that we can then report to other states that it is possible begin to, if at least not turn things around, at least dramatically mitigate the rate of environmental change owing to global warming. But my final answer, when the person I told wasn't impressed by that, I just said, vote. We have to kick climate denialists out of office and do something about this. I don't have any political power. The people that have power to do things, like pass bills supporting the study of geothermal energy and how it could be added as another weapon in our bag to do something about global warming. We can pass these bills, and so just by showing as a state, hey, we're voting for people that are going to do something about climate change and do something consistent with the scientific research that's conducted, as opposed to listening to people who know nothing about climate change and following their lead, which will be a disaster. So that would be in a nutshell, my answer.
Thank you.
Yes, Les, this is Jim McKenzie. I can't resist, but to let people know that one of the primary goals of 350 New Mexico is to do precisely what you just outlined.
Mm-hmm.
And so we're coming up on a legislative session after the first of the year. And if people tune in and actually engage with us, we will let them know what the appropriate bills are that they should be supporting and whom they should call to their legislators and their senators. And so an important part of our work is to mobilize people towards that end that you talked about.
Yes, I'm aware of all the great things that 350 does, Jim. And
Raven, it's so nice to see you here. You have a question. Are there current efforts to diversify the panel? And I'm not sure what that means. Would you mind unmuting and explain your question, please?
Hi, Steffi. Hi, everyone.
Hi, Raven.
My name is Raven. I'm a recent grad from UNM EPS. And yeah, so I know you showed pictures of all the members that sit on your panel. And yeah, so I was just wondering, are there current efforts to diversify the panel to include more POC frontline communities who are actually enduring disproportionate and direct effects of these climate impacts that you just described? And if so, and if not, do you see like a value in that, or yeah, that's kind of my question. Thank you.
So Raven, by panel, did you mean the scientists who wrote the report, or do you mean the 350 committee? What specifically are you asking about?
The people who wrote the report. It seemed like there was leaders on that. And
so let's set questions for you.
I'll try to answer that. It's the same kind of question that my department has been trying to address over the past several decades. How can we diversify our faculty? How can we diversify our graduate and undergraduate populations? And because, and I'm happy to report that we are seeing dramatic increases in diversification, at least in many STEM fields, not all, but many STEM fields, not just at UNM, but throughout the country. And this was really demonstrated nicely at the GSA meetings, where several of the top awards given by GSA are no longer going to old white guys like me. More and more and more, they're going to a diverse population, and minorities, women, et cetera, et cetera. And so we're beginning to see change. It's just, unfortunately, and it sounds like a terrible excuse, But in this case, the idea of the governor, who I'm sure was behind developing this panel, was to let's pick the top scientists in this state who are doing hydrology, soils, and climate science. And at this point in time, it just happened to be the crowd you saw. I'm absolutely confident that that a panel like that in as little as 10 or 20 years will be quite different, far more diverse. I see that it's already clear to me that it's happening, at least in the earth sciences, in my field, in the quaternary geology, Steffi, geology and soils. But also, it also depends on the type of panel. I mean, if you want to develop a panel on how is climate change being affecting communities of color in our state, well, that the panel you saw is not the panel that would be picked. I'm sure it would be a panel that would be substantially more diverse, reflecting the different goals and needs of the panel. That's just my off-the-cuff response, but I understand your question.
Lucy Stannis was asking, what are some key adaptation strategies we can focus on?
Could you repeat that question?
What are some key adaptation strategies we can focus on?
I guess I'm not, well, I mean, on a personal level or as a state, as a universe, I mean, on a personal level, well, I have solar panels. You know, I recycle. I mean, you try to do what you can on a personal or family level. In terms of at a higher level, you know, I understand who controls things in the state, and it's politicians for the most part, and corporations. So I can't vote for who's on corporate boards, but I sure as I can vote for our representatives. So I make sure that I vote for people who understand that climate change is happening and why it's happening, and are going to support the kind of things I want to support. So that's how I adapt at a personal level. But if you're talking about how do we adapt as a society, as a people, that's a far more difficult and complicated question. And I don't think I'm really prepared to answer it, other than to say the more people that are educated, the more people that can be taught to critically think, the better off we're going to be as a nation. That's my personal view.
Lucy, was there any follow-up you had to that? I think, you know, one of the, Craig's on the call. I think one of the most important thing is that we really try to mitigate rather than adapt. I mean, we all have to adapt to make sure that we can protect as many people as possible from the effects of climate change. But we are really trying to mitigate, to slow climate change down, and to switch from fossil fuels and to go to renewable energy, and also to get gas and fossil fuels out of our homes and our industry and our buildings, so that we can ramp down the use of fossil fuels and slow climate change down.
Well, and Steffi, as you know, I completely agree with you, but I would say that given the accelerating pace of climate change, I can tell you that my close friend and collaborator, Joe McAuliffe in Phoenix, I know how he's going to adapt. He's going to leave Phoenix. It's no fun to live where it gets over 130. And that's what you'll be seeing in 2-3 decades in Phoenix.
Well, already this summer, you know, a lot of people, heat is emerging as a public health emergency.
Yes. 36 straight days over 110 in Phoenix last summer.
Karen Nelson was also asking about, you know, what good is it when we work on all these bills and then the governor vetoed it? And Tom mentioned that there's a good chance the geothermal bill will not be vetoed again in this session coming up. And we think that maybe the EV tax credit will also pass, since the governor suggested that at a recent transportation conference. The rule of thumb is it takes often 8 years to pass a bill, unfortunately, but there's a lot of things that we can continue to fight for to make this easier for our legislators, like paying them and paying their staff, so that they don't have to rely on lobbyists for all their information all the time. Nancy, did you want to say something? And then Jim?
No, I didn't have a question. It's just this is just such an important report, as I wrote, and it's just really disturbing that it hasn't been released, that so many people don't have an understanding of the impact, not just of our water, but of our land itself, of our vegetation, of our forests, of the whole way the state looks and the way we interact with it. So it's just so important that this information goes out to a wider audience so that people can understand the importance of mitigating climate change.
Steffi, can I make one point?
Please do.
Nelia went out of her way to make sure that every one of the chapters has a sort of a technical geeky terms removed from it, so that it's generally understood. So you don't have to read the whole thing to get the gist of what someone like Dave Gusser thinks about to what extent warming is occurring, how rapidly it's occurring, et cetera, et cetera. So I think I just wish it could be released, because I think it's very readable, those parts that make it extremely readable.
And there are the webinars are posted on online too. And besides Les, my other favorite one is the one by Craig Allen about trees. I think that's really, really amazing talk. So I really suggest you look at that one. Jim?
Thank you. And thank you, Les, for this wonderful talk. It's a lot to ingest and a lot to process. I want to say that this fight we're in against the denialism, against business as usual, as you called it, is a daily struggle, and it's made up of a series of skirmishes, if you will, if you want to go continue on with the kind of the war analogy. I just want to let people know that tomorrow night at the Bernalillo County Commission meeting at 5 o'clock, there's going to be an important discussion, because one of the things we're trying to do is hold the line on any new fossil fuel infrastructure. And the New Mexico Gas Company is proposing to spend something like $200 million on an extensive compressed liquefied natural gas facility and storage facility in Rio Rancho. And the subject at tomorrow night's Bernalillo County Commission meeting is a proposal from Chairman Baca to go on record as opposing the LNG facility in Rio Rancho. And so it would be helpful for as many people to show up to show support for that resolution. One resolution or one facility is not going to change dramatically the path that we're on, that you've outlined for us tonight. But years ago, the excuse was, well, New Mexico is so insignificant that if we change our carbon output or our methane output, it really won't make any difference. Well, that maybe was true a long time ago. But as you showed initially, we are the second largest producer of oil and one of the major producers of methane. The leakage rate of methane is enormous. It's approaching 10% of all produced methane is leaked. And so we are an international player. The Permian Basin is the largest oil play in the world right now. So this idea that we can't really affect anything because we're just little old New Mexico is out of date, and we need to put our shoulder to the wheel. Thank you.
Great point. Great point.